Hi Year 12. In today's video, I'm going to talk a little bit about position vectors. So I'm first of all going to show you what these things are, and then we're going to look at a few problems that involve these things. I'm going to talk a little bit about what these things are used for, and then I'm going to get you on with some problems as well. So, starting off then, we're going to be looking at the XY plane, which I've got on the screen. And I'm going to start off by putting a coordinate somewhere on it. So let's put a coordinate here at 4, 3. Okay, and let's also label this up with capital A as well for our point. Okay, so this is labelled up with a coordinate. A coordinate only really describes a position on the plane. Okay, so what I can do though is if I'm an animator and I've got an object over here at this coordinate, I can move it across to a different coordinate. Let's suppose we've got -1, 6. This is going to be my point B. So again, if I wanted to, I could translate from point A to point B, but there aren't really any operations that act on coordinates themselves, okay? My point is coordinates only really describe positions, not movements. But a vector is a much more powerful object because it can deal with that kind of action that you want to perform. So let's draw the vector that goes between A and B like that. That shows the movement between the two. So a vector can do what coordinates can't. It doesn't really make sense to write a coordinate equation, if you like, that says, right, here's coordinate 4, 3. I want to add another coordinate and get myself up to -1, 6. Okay, that notation is bad because, as I said before, coordinates don't really have operations that do this kind of thing. But what we can do is we can get around this problem by introducing position vectors, which are much more useful. So a position vector basically takes a coordinate and assigns it with a vector that comes out from the origin, okay, which I'm going to refer to as O or naught. So the position vector of point A is this vector here, and because it points towards big A, I'm going to call it little a. And clearly, to get from the origin to 4, 3, I'm going to need the vector 4, 3. Okay, and similarly, if I want the position vector of B, that's going to be the vector coming out from the origin up towards B. And again, we'll call it little b because it goes towards big B. And that's going to be -1, 6. Right, so the blue vectors are the position vectors. Let's write down what we've just done. Let's have their tail at the origin. Okay, and our examples have got A and B are the position vectors of big A and big B. Okay, and then we could just as easily write capital O to capital A for our vectors as well. So this is the same as O to A, this is the same as O to B. Right? So when we're doing calculations, it's very helpful to associate every coordinate that we've got in our problem with its position vector, because then we can move around this grid using combinations of these vectors. Right, so that's the basic definition. Now we've got the idea behind it, we can look at some problems. So here we are, here's the first one, and I've taken these from the Dr. Frost PowerPoint. If you want to have a look at them yourself, I'm going to attach the PowerPoint as well. So the points A and B have coordinates 3, 4 and 11, 12 respectively. That just means that this is A and this is B, same order as over here. So when I see coordinates, I want to associate it with their position vectors. And the first two parts are going to be derived immediately from what we've got in the question. Okay, the position vector of A is just the origin to A, but I need to get to 3, 4, so that's just the vector 3, 4, like that. Okay, nice and simple. Same way, position vector of B is just the origin to B, which is 11, 12. All right. If you want to draw sketches, I think that's going to be quite a useful thing to do for all of these questions, particularly when they get more complicated than this. But for now, we're just looking at what we've got in the question. Right, the vector AB, you can work it out by looking at the coordinates if you'd like, but I think a sketch might be useful for forthcoming questions. So let's put the origin, and then we've got these 2 points A and B. I'm not going to put them in particularly in positions that kind of correspond to where they're meant to go, but that's going to be okay. So here's A, here's B. What I've got from part A and B are the position vectors. That's going to be this one. So this is 3, 4. And then O to B is this one here. That's going to be 11, 12. And what we're after is the vector AB. So let's draw it on. The vector A to B is here. That's the one I want. And if I want to get from this position to this position, what I can do is, using the red vectors, is subtract the vector OA and go back towards the origin, and then go forwards again towards B that way. So I'm going to write it as a little vector equation. AB is A to the origin plus O to B. Okay. Now, what we've done beforehand is we've worked out O to A. So you might want to do the negative of OA plus positive OB, right? Which is the same as saying this positive vector minus this vector over here. So in general, this is quite a useful statement to have. The vector A to B is OB minus OA. Right? You can use that for pretty much any question that asks you to go from one point to another. So this is the position of the destination, and this is the position vector of where you started. Okay, it was quite useful, that. So as vectors then, this is going to be OB is 11, 12. And we're going to subtract OA, which is 3, 4. And that's going to give us 8, 8. Okay, so that's just an example of using those position vectors like that. Okay, next up. So now we've got vectors written in component form. We've got them in I and J notation. This one is O to A, 5i minus 2j. This one's A to B, that's 3i and 4j. And we want the position vector of B. And again, if you're confident looking at what you've got in the question and working it out, then you can do that. But I'm going to do a sketch just in case you're not sure. So, same as before. Here's the origin. I'm going to try roughly to get this in a reasonably good position this time. So 5 minus 2 is going to be about there. That's going to be A. And 3i and 4j is going to be 3 that way, 4 that way. It's going to be roughly there. Okay. So O to A is given, that's 5i minus 2j, and I'll put that on. The vector is 5 minus 2. Now A to B is this one to this one, and that's going to be 3i and 4j. That's 3, 4. And we want the position vector of B, which from the definition, that's just the vector O to B. That's this one. Okay, and then from the picture, it's O to A plus A to B. Okay, it helps to kind of make this kind of linking chain of capital letters to get yourself from one starting position to the other. So what's this? O to A is 5 minus 2. AB is 3, 4, and we're adding them together. So that's 8, 2. And that's O to B. Okay, brilliant. Part B, the exact value of the absolute value or the modulus of OB in simplified surd form. Well, that's just the length of this vector here. And given that our vector is 8, 2, we then know that we've got the components of 8 and 2 like this, even though it's not to scale. And we can use Pythagoras to get its magnitude. That's going to be given by this. That's the square root of the sum of the squares of these bits. 2 squared. Now what's this? This is 64 and 4. That's root 68. Now we've got to look for trying to get into a simplified surd form. So I reckon you can probably get a square factor out of this. Now what does this divide by? I think it divides by 4. So that's root 4 root, what's that going to be? 68 over 4 minus 30 minutes, that's 17 fours. There we go. And that's 2, so that's 2 root 17. There we go. Right, so don't forget your surd knowledge. If you can find a square factor, you can simplify a surd like that, and that's normally what it's going to ask you to do. Right, finally then, some questions might have more of a kind of geometric aspect to them, so you might be definitely wanting to draw a sketch for these, particularly if it's a shape that you need to be recognizing. So you've got 3 vertices of a parallelogram. The coordinates are given there, -2, 2, 1, 6, and 4, 3. Now we want all possible coordinates of the 4th vertex of the parallelogram. Now when it says all possible, that's going to probably suggest to you that there's going to be more than one possible answer, as we're going to see in a second when I draw these on. So let's first of all plot these points, and then we'll think about where the 4th vertex could possibly go. So we've got -2, 2, that's going to be here. We've got 1, 6, that's going to be up there. And 4, 3, that's here. All right, so coordinates are given there. We don't particularly need to put the position vectors on if you don't want to for this question, but we're looking at the grid now to figure out where the 4th coordinate can go. So I think it'd be sensible to join these together. So one possibility is to join these together like this. And you can do it just by looking at these coordinates, I think. I think you can probably get the vectors between these quite easily. I think let's probably label these up first of all. So let's label these A, B, and C, which is A, B, C. So the vector A to B, well, we can subtract B minus A and get the vector that way, or just think about the differences between them, and that's going to be 3, 4. And then the vector B to C is going to be 1 to 4 is 3, 6 to 3 is -3. Okay, we've got the grid though, so you can actually count the squares in this case. Now, by joining the points in this way, we can figure out a 4th point by moving these vectors around. We know from a parallelogram that opposite sides are equal. And they're also parallel, which means that the vectors are equal. Okay, so if our vector BC is 3 minus 3, then on the other side, we're going to have the vector 3 minus 3 going down this way as well. 2, 3. It gets me to there. So this could be point D, which I can work out by going from position A, which is at -2, 2, and adding the vector 3 minus 3. And what's that going to give me? It's going to give me 1 minus 1. Okay, so as a position, as a coordinate, that's going to be 1 minus 1. So let's put that over here. That's one of my possible answers. Okay, now that's only one of these positions. You might have thought about where else this 4th vertex can go. So let's think about that now if I get rid of this stuff. Okay, I'm going to put the vertices back on again. -2, 2, 1, 6, 4, 3. Now, if I join these a different way, it's going to give me something different for my 4th point. If I join them this way, then that suggests that there should be a coordinate somewhere over here where my 4th vertex can go. So let's now work out the vectors on these edges. I've got -2, 2 to 1, 6 again. That's going to be 3, 4. A to C is going to be 6, 1. So to get to point D somewhere over here, I'm going to need to put the 6, 1 vector onto the end of B over here. So if I add this one on, 1, 2, 3, 4, 5, 6, 1, that's going to go over to there. Okay, so equal vectors on the opposite side. That's going to get me from B, which is 1, 6, plus 6, 1, that's going to get me to 7, 7, as I've got on the grid. Okay, that's number 3. Now, I believe there might be a third option, but I'm not sure. Let's maybe see if we can join them up in a different way and get a different answer. Right, so we've joined them two together, we've joined these two together. I think we can join them this way. To put a fourth vertex over here somewhere. So that makes sense. So let's think about these vectors now. So C to B, I'm going to write that properly this time. C to B is O to B minus O to C. That's using our property before, where you do the second point minus the first point. That's going to be 1, 6 minus 4, 3. That's going to be minus 3, 3. And then C to A is going to be OA minus OC, which is minus 2, 2 minus 4, 3. That's minus 6 minus 1. So we can then either put this vector on the end of A or this vector on the end of B. It's up to you. I'm going to put minus 3, 3 on the end of A. So that's going to go out this way. 1, 2, 3, 1, 2, 3. So this point here is going to be OA plus CB, which is also the same as A to D, which is going to be minus 2, 2 plus C to B is minus 3, 3, which is going to be minus 5, 2 plus 3 is 5, which we've got on the grid as well. Right, so I believe those are the only 3 possibilities where this third point can go. So hopefully that will make sense. If you need extra help, then you can welcome to let me have an email, so drop me a line, see if I can help you out. I'm going to touch some questions to show my homework, and I'll get back to you. Have a good day, Year 12. I'll see you soon.